So systems of description of tool geometry. In the previous class we discussed about tool geometry. Tool geometry means it includes the features or details of a cutting tool. It includes the surfaces, so that is rake surface and two clearance surface. Two clearance surfaces are so major flank and minor flank, or major clearance surface or minor clearance surface. Okay, so those are the three surfaces. Then we are going to consider some of the angles, rake angle, then clearance angle, then some cutting angles. Okay, so and other than that we are going to consider the cutting edges, major cutting edges, edge and minor cutting edge, or side cutting edge or end cutting edge. Okay, so this tool geometry consists of surfaces, then cutting edges, then angles. Okay, so other than that we also consider shank and nose. Okay, all this constitutes tool geometry. Okay, so this tool geometry can be visualized in different ways. Okay, so based on that we have different systems to describe the tool geometry. So one of those systems is tool in hand system. So if you hold a cutting tool in hand and if you visualize its details, okay, that is the tool in hand system. So you are holding the tool in hand and we are visualizing its geometry. Okay, so in tool hand system, it is a system where only the salient features of the cutting tool point are identified or visualized. Salient features means again these three surfaces, that is rake surface and two clearance surface, then cutting edge, major cutting edge and minor cutting edge. Okay, those are the salient features. But here one of the major drawback of tool in hand system is, so there is no quantitative information regarding value of the angles. So that means if you cannot measure the angle, so it may be rake angle or clearance angle, in tool in hand system it is not possible for us to measure its angle. So that is the demerit associated with tool in hand system. Okay, so other than that, considering the reference, so there are three types of systems. Okay, you can choose machine as the reference, or you can choose tool as the reference, or you can choose work part as the reference. If you choose machine tool as a reference, then that is considered as machine reference system. It is called by other name, that is ASA system. Here full form of ASA is American Standards Association system. So the other name for machine reference system is American Standards Association system. Okay, so in tool reference systems, so you are considering tool as a reference. Again, in that orthogonal rake system and normal rake system, we are going to discuss about these three in detail. Okay, and there is another system, that is work reference system, where you are considering the work itself as a reference, but it is not included in the syllabus. Okay, in this class, so I am going to discuss about tool in hand system in brief and machine reference system in detail. Okay, in today's session, so I am going to cover the first two systems, that is tool in hand system and machine reference system. Okay, so next, so this is the representation in case of tool in hand system, basic features of single point tool in tool in hand system. So here they have considered as turning, that is a single point tool used for performing turning operation, that is in case of lathe machine. Okay, so this is the single point cutting tool. This is called as shank. This is the rake surface, and this is the principal clearance surface or major flank or principal flank. Okay, so and this is the minor flank or end flank or, okay, so clearance, auxiliary clearance surface. So there are three surfaces, rake surface, major flank, minor flank. So it is called by other names also, that you can see here. So then this is the nose. Okay, if it is having a curvature, then it is called, it will be having a nose radius. Here it is a sharp corner. Okay, so usually it will be having some nose radius and it will be having a curvature. Okay, so then there are two cutting edges, principal cutting edge, that is major cutting edge, and minor cutting edge, also called as auxiliary cutting edge, or it can be called as side cutting edge and this is called as end cutting edge. Okay, so in this tool in AND system, you can see only these surfaces and you can see the cutting edges, whereas it is not possible for you to describe the tool angles. So that is, you cannot measure the rake angle or you cannot measure the clearance angles. That is the demerit associated with tool in AND system.